Hey folks, welcome back to the channel. I think I'd like to start doing a midweek video sometimes, a little shorter in length.
Oh no!
Or maybe, I don't know. But at least it'll be midweek when I have content. And I think I have content for this particular one. So I wanted to go over it with you and kind of share it. This is the BXA tool holder that came with the Grizzly G4003 lathe, this one over here. And you can see this is the piston type. So when you turn this, how it locks the tool into the dovetail is the piston goes in and out. I don't really like this. It's not clocked properly. You can't change the clocking inside here because the eccentric on this inside is not clockable to the outside. We essentially have to re-drill and tap a hole, which it really should have like 3, to make this clock right, because otherwise it tightens up back here when the tool holder is like this. So I have a dovetail in the front, which would be suitable for a boring bar, and on the side for turning and facing. So I didn't really like this style anyway, so I got a BXA from Amazon from All Industrial Tools, which is a wedge type. I think these wedge types is much better, and when you turn a wedge type, you can see that the wedge goes down and pulls the tool in and really locks it in place, because this is a wedge style. It's kind of hard to see. There we go. So that's what I want to do. So the issue we have here, and this is not something that I wasn't expecting, because it says right in the literature on the sale, you know, for the, I should say the, what they call it, an ad in Amazon there, I don't know, the sales thing, that you're probably going to have to do some machining on the base that comes with the BXA wedge style to make it work in the T-slot of your lathe, and that is definitely going to be the case. There's an alternative here that I'll discuss with you, but if you put this wedge BXA down, it won't go all the way down because there is a shoulder area, a larger diameter in a shoulder at the base of this one that, oh, this is heavy, that there is a counterbore in the bottom of the piston style that accommodates that, okay? So we have 2 choices here. Well, really 3. We can take this, and I thought about doing this, and putting it on the mill and using the boring head and just boring a counterbore, because I really don't want to modify this, the original part that came with the lathe. I want to keep it with the original tool holder, and you know, it's not terribly doesn't look terribly rigid anyway. You know, it's kind of cut back, and you know, I'm like, I think there's a better way to do it. Plus, the other way would be that we turn this down. But how do we turn it down when we don't have a tool holder? Because this is the only tool holder as far as the quick change that we have. So I'd need another lathe to modify this lathe. So obviously I don't have that. So I think the best way to go here is to take this base, and we are going to mill this down. I think that's why they provided to you this big slab of steel, so you can mill this down to fit whatever T-slot you got. Yeah, this stud is a little long. Well, I guess that's not a bad thing, but in this case it is, because when you put, even when this is down flush on the bottom, which it basically is now, this is pretty high extending. So that's another thing they probably do. They just give you extra length so we can cut this down, you know. And yeah, we can, I think we can do this no problem. Since we got a milling machine, why not do it, right? So I'm going to make some measurements of the T-slot, and we'll go put this in the milling machine. Just do it, hopefully right in the vise, and not have to do any fancy setups. And then we'll cut it down using some carbide. Here's our dimensions. I don't know what happened here. These dimensions are actually completely wrong. I don't even know where I got those numbers from. But rest assured, I didn't scrap the part, and I did correct my errors. There's a little bit of a rectangle shape to this. It's not a perfect square, but the overall width in this orientation is pretty good. It's just inside this chamfer on the compound. So I think I'm going to use this side, and we'll mill it like that. So I'll have to make some marks so I don't screw that up. When do I ever do that? Figure out the exact order of operations as we go here, but it's a pretty simple, I mean, this is a really simple thing. As long as this is not made, you know, harder than a coffin nail, which it is probably a little hardened, but most likely case hardened, we should be able to cut it no problem with carbide. All right, all set up. This is gonna throw chips everywhere, but we gotta take 112.5 thou off of each end to bring it down to the width that we need. Then that way we can reference off that width for the depth of the step rather for the slot. So that's what we're going to do. Now these services are not machined, or at least machined very well. If they machined it with a hacksaw. So I think what we might do is, we'll just take it. Let's see how it cuts. We'll just get close, because I want to take it off evenly so the screw is in the center, you know, the bolt, the stud. You said stud. All right, let me zero out this DRO. Let's go, I don't know. Let's just do 20 to start with. I want to see how it cuts. Let's bring the Y on the back side of the tool. Oh yeah, that's pretty hard shit right there. I think we're to be indexing inserts here pretty soon. They don't look too bad. I mean, this is the original edge. I've never changed these since we got them. You know, this head. So I'll just keep running it, and if we burn it up, I'll index them. I got a crap load of inserts for this. So anyway, let me whittle it down, and then when we get close, we'll come back. Should be the final cut, or at least close enough. I brought the work out on the lead side of the cutter instead of the back side or front side. It seems to cut a little bit better. Instead of hitting it square, that's the reason why you do that. You don't want to hit that edge square. It kind of beats up the inserts less. All right, here's the first side done. Came out pretty good. You can see that. Yeah, not bad. So I remeasured it. I've got 110 thou to come off the other side, so I was 2 thou off. So I think this, you know, this is not the most rigid mill in the world, and I think what's happening is it's pulling the spindle down a little bit, even when it's locked. So I'm just gonna go shy a couple thou. I went shy 10 thou. Actually, I had to take more, 10 more. I should have taken 8. So we'll just go a little shy, remeasure, and then take the appropriate amount. That's 50. Seems to like it better when the cut is deeper. There's 100. Okay, I don't know where the guy who made this drawing got this dimension, 2.760 as the overall. Although it's too big, it didn't really cause us any problems. But you know, the major width of the slot is 2.012. How in the heck did he get that wrong? For crying out loud, you flunked grammar school. Yeah, thanks for reminding me. So right here, where my fingers are, is that dimension at 2.760, which is okay. It's not going to cause us any problem. Just turn it to the side, and we're going to put the slots here and here. But we need to bring this to overall dimension, but we lost that outside reference, so I calculated it out from the inside of the hole. I calculated out to be 720 thou for the overall width of this to fit into the slot once we do the step. Again, from the center of the hole, the edge of the hole rather, not the center. So I'm referencing the edge of the hole each way. That way it's in the center still. Like I said, I don't know what the bonehead was thinking, so I ended up putting this in the bandsaw and hogging out about 1/4 inch on each side rather than having to mill it. So I think that's going to work out a lot better. Save the machine a little vibration. All right, we just got to deburr it, but I've gotten both sides cut now with a reference to the center thread. And how we double checked this before I finally made my dimensions up, as far as as far as I decided on them, I decided to bring each side down to 0.710. So if I do 710 plus 710 plus the diameter of the hole, that brings us to 1.99 something, 996 or 998, whatever that is. and the slot is 2.012, so it gives us basically about a 12 thou or so clearance for this to slip in there, which is fine. I figured, you know, 6 on the side would be fine, 6 thou. So this is all done. I got to deburr it. Now we got to set it up to do the steps. Well, before I do that, I need to take the overall thickness of this, or height of it, down 65 thou. So what it'll do is it'll be about 10 thou below this edge, you know, so it can actually pull it down onto here instead of onto the block itself, which you don't want. I've already measured this out. I need to take 65 thou off of it. So in this particular case, because I'm not using a great vise here, if you go directly up against it with the movable jaw, it wants to kick the part up because the jaw wants to kind of do this. So the trick to that is you put a piece of like copper wire. In this case, it's about, you know, 12 gauge or 10 gauge copper wire from the ground side of a you know, piece of wire, a Romex. And what that does is it shoves it this way so you can actually hammer it down and get your parallels tight, and then you know it's not going to go anywhere. And this sucker is pretty tight, so we're not going to lose the part either. So that's a trick you can do on stuff like this. So again, I'm going to touch off and probably just, I don't know, maybe we'll take it in one pass, but most likely two. Oh, and I forgot to mention, I went ahead and re-indexed the inserts, and so we got a fresh edge, and that way we can at least roughen, if not finish, the steps with it, because you can side mill with this. But I'm thinking, since this cut in the bandsaw so easily, I might just rough it in with this and then switch over to a brand new sharp 1/2 inch end mill with some cutting oil, and maybe get a little bit more accuracy out of it. We'll see. That's 40 thou, by the way. Yeah, nice surface finish. All right, I'm just going to go ahead and take it down to the 65, and then we'll figure out how we're going to hook this up for, you know, doing the steps. All right, here's the setup. I got it hanging off the left side. It's just easier for me to see because it's closer to the light, too. And unfortunately, that's going to throw chips back at me. I probably should have done it this side and shoot them back there, but again, I have a harder time seeing over there. So I'm going to keep you guys here, and I'm not going to film the whole thing, but just some cuts. And I put these 1/2-13 holes in the top of the vise. There's one up here and one here, I don't know, a couple weeks ago, just for this purpose. So I could use my mill straps, you know, to clamp stuff down with, and then, not strap, but the mill clamps, and then reach across to something that's in the vise. So this is going to keep downward force, so the thing doesn't want to go down with the tool load because we're working off the edge. So I think that'll work fine. I originally was going to put a gauge block in there as a stop. That way I can just flip it around and pick up the same spot, but it's either one or the other in this configuration. If I had two more holes, like one here and one there and one there, one there, which I'll have to do, it would work a little bit better. So eventually I'll make that change. But you know, you develop these things as you go along to help you out. So according to my redrawing of doing it right, I got to go down a total of 315 thou. And I have to go in, which I've already marked off. It's a total of 372.5, and it doesn't have to be that accurate. So I think I did it to like 365 or 355, I think. Yeah, so I'm a little shy. 60 and see what it does. That worked okay. All right, you get the point. I'll come back when I get it roughed in. All right, I just measured it up and needed to go 10 more because it was pretty much at size, but we need to have clearance in there for this thing to fit. Whoops. It doesn't require the accuracy of a mic. I just can't get my 6-inch stair at 120 in there. That's 245. That's what I want because the slot's about 250. So this gives us 5 thou, which is plenty of clearance for that to go in and out. It's got actually about 6.5 thou, so I think that'll be fine. I mean, I don't want it to be too sloppy, but I don't want it to be too tight either. Well, not this. All right, side 2. What I did was, instead of touching off on the top and measuring, I just zeroed the DRO where the other one is. So instead of going in graduations of distance as far as 60 or 120 or so each cut to get to a dimension, we're going to bring it down to close to 0 and then measure it and see where we're at. And I've already, that's of course on the downward. I've already touched off on the side and moved it in the appropriate amount for the depth of the step. I'm not going to film any of this stuff. You've already seen it, so we'll come back when we're done. Anyway, I'm going to take it out because the numbers look good. The micrometer and the depth mic and the calipers say that this is done and it should fit. Let's take it out and deburr it and let's find out for sure. Moment of truth. I haven't tried it. I promise. Scout's honor. Uh-oh. Somebody's math was off. Yeah. That fits there, but we have got, oh, I know what it is. You know what I didn't account for is the radius. This is a sharp edge, and that is not. But, you know what? I've got a chamfer tool. No, wait a minute. I've got a, I don't know what I got, but I got something that we're going to go ahead and just put it back in and cut that radius. That's the, I was thinking about that before going, I don't know how I'm going to cut this radius because I really don't have anything good for it. So I'm going to figure something out. We'll cut that radius because this definitely fits. Good there. Good there. So it's just the radius. Yeah. And again, I was thinking about that, but I just didn't have a solution at that time because it's a sharp edge underneath here. We'll go ahead and use a dovetail cutter to cut that relief in there. I forgot I had this. This is part of the tooling that came with this old mill. I've never used this before, but it seems pretty sharp. Unlike me, with my mat skills the way they are. So I think what we're going to do is do a classic reach around with the piece of paper trick and pick up the bottom until it pulls my paper out. And then we know we're a couple thou away. I set a 0 by bumping it and then hit the DRO, the quill DRO, but I don't trust that. So we'll just do this. As long as we get it, I mean, if it's just off the surface by thou or so, it's going to still work. But there it goes, just touching it. See? Okay. 1 thou. Yeah, this is off because that paper is more than 1 thou. Yeah, we're still touching too much. I don't like that. All right. I think that should work. If not, we'll just bump it a little bit more and then take it out. Let's go like 15 thou. I don't know how this high speed is going to deal with it. We'll put a little oil and see what happens. Let's just go a little bit more to make sure. I mean, that should be fine. I just didn't want to take any off the flat, you know, to screw it up. Those really have to be pretty even, otherwise the bolt, you know, that goes through the stud bolt, whatever you want to call it, is going to, you know, want to cock a little bit. You said cock. All right, I'll do the other side off camera. We'll go back over there and see if we are good. All right, here we go. This time I tried it. It may or may not work. Actually, both of those are correct. Works good this way. Turning around, she don't want to go in. And I'll tell you why that is I don't have these two ends exactly even from the edge. There's probably maybe just a few thou variance, or 5 thou, 10 thou even. But it goes in fine this way. So that means the slot must be the same way. Slot must be a little bit off. So well, that's all right. I mean, it goes in this way, it's going to be fine. I mean, really no other way we can test. I can test this. Check this. See where we're at on that. That's 344, 343, and that's 345. So it's within 2 thou. It should be well within tolerance. But it's fine. I mean, it goes in this way. Who cares if it doesn't go in the other way? It goes in perfect this way. There's very, very little play in this thing. And we are just below the surface. So let's see how much we're below the surface when it's pulled up. We'll just kind of simulate that. Should be about 10 thou is what I wanted. Just kind of lift it up like that and just get an idea what it is. Maybe 5. Yeah, 5 thou. Actually, I did do 5 thou clearance on it. Yeah, because, well, anyway, that's what I did. So we got 5 thou clearance, so it's below the surface when it's pulled up. That's what we really need it to be. It doesn't have to be any more than that down below. Anyway, let's try it out. All right, I got the long shaft on. Okay, I won't let you down, said the wife.
That's what she said.
This is too long, but we'll cut that down. And the reason why these things are not exactly right is because they're universal. They're universal, and it says right there on the Amazon thing, may require machining, like my wrench, may require machining to make it fit to the T-slot on whatever lathe compound you're putting it on. Oh yeah, that feels good. Now I gotta find what I did with the handle. I think it's still in the box. Well, they shorted me a ball end of it, or some sort of a grab point. There's not one in the box. I kind of noticed this the other night, but I'm like, what the hell? But it ain't in there. But the handle from the other lathe, the other, not lathe, shit. The other, you know, tool holder, sort of fits. I brought a tool holder out. Not sure if the ones that came on the other tool holder would fit this. It would be awesome if they did, because you can never, ever have enough tool holders. All right, so there's your standard tool holder for this guy.
Oh, yeah.
That's nice. So we can turn her a little bit if we wanted to do some, a little bit machining at a little bit of more of an angle, a little bit this, a little bit that. And let me tell you something, this sucker is not going anywhere. Nice and stable. It'll be solid, no problem whatsoever. So, yep. Real happy with the way that came out. And it's facing backwards, so it's not over the work or anything. I kind of prefer it over to the side here, but you know, it is what it is. Now let's take a look at one of the tool holders from the other deal and see if it fits, just for the hell of it. Oh yeah, perfect. Look at that. So this is a tool holder with a tool in it that was sitting that way when I got this thing. And it is on there, baby. Yeah, yep. So what do I do with it next? This machine part is going to get cold blued as soon as I get some. And I gotta cut this down to length. This is too long, doesn't need to be this long. She's righteous. We didn't have to modify the bolt on the other one or modify this. We just did what the instructions basically said to do. Machined the material they give you for the T-slot. All right, stop the presses. The ball was there, or the handle end rather. I tried putting a different ball on it and then realized it was sitting right here, so it must have been in this bag and I didn't see it, so my apologies to them. I just got to tighten this up and we're 100% except for that. All right, folks, this video's done. I got a crap load of cleanup and vacuuming of chips to do. Got a little off on my math there. I don't know how that happened. I mean, to be honest with you, I don't know where those numbers came from. What are you talking about?
For crying out loud, you flunked grammar school.
Yeah, thanks for reminding me.
Jerk. Came out real good. I finished the bluing on it. That came out real nice. I'm not very good at that yet, but I do it very seldom, you know, so it's one of those things, I guess, over time you get better at, right? Kind of like, well, you know what. Yeah, I really like the way this came out. It was a fun job to machine, and I really like this type of tool holder a lot better than the other one, this wedge style. What I also did was I cut down the overall length so this thing wouldn't be sticking up so high. Of course, I blued the end. Before that, though, I cut down the inside one that goes into the T-nut itself because it was bottoming out on the compound. I didn't want that to be putting upward force, possibly distorting this, and maybe, because I did cut this back about 10 thou more to make sure that it was down below the edge of the compound. So just in case, I just wanted to make sure that that would not penetrate through, so it's just shy of flush when it bottoms out the threads in the T-nut itself. I'm not going to be able to have content for Wednesday or midweek video all the time.
Oh, thank you. Thank you.
But every now and then when one comes up or something comes up, I will definitely consider doing that and putting it up on the channel. If you want to see more of this stuff and other crap that I got going on, you know what to do. Stick around. We'll catch you on next video.